2 plus 2 is 4, minus 1, that's 3 quick maths. Everyday man's in the class, doing problems. See that problem board, that problem is easy. Thanks to Mr. Ng.
Yeah. Hey guys, let's go over quiz number 3, 1.1 to 1.2. Which graphs represent a quadratic? So a quadratic function would be something like to the second power, and it looks like a u or an upside down u if it was a negative x squared. A is not. This is called a cubic polynomial, which we're going to learn later. Our correct answer is B. This is a quadratic. Okay, C, although it kind of looks like it, you'll notice that has extra bumps in there. So it's not C. D is a quadratic. So this one tells you to select all that apply. And E is not. This is an absolute value. This one has the equation y equals the absolute value of x. Question number 2 says, find the average rate of change from the function given the interval. So this looks a little bit different, but it's essentially the same thing, like something like this, 3, 7. And what we did is, number 1, we evaluated this separately. So this is your x1, this is your x2. So you're basically just going to plug it into the function. So let's put in 3. This will give us 9 plus 27. So f of 3 equals 36. So that order pair is going to be 3, 36. Okay, let's do the other one now. We're going to use 7. So f of 7, put in 7 for every x value. 7 squared plus 9 times 7. 49 plus 63. This will give us 112. F of 7 equals 112. Okay, the next thing you're going to do is we're just going to find the average rate of change, which is basically slope. My formula is y2 minus y1 over x2 minus x1. My y2 value is 112. And I want to point out that it must have the minus sign in red. My y1 value is 36. My x2 value is 7 and 3. So this is going to give us 76 over 4, which reduces to 19. We have an average rate of 19. Basically, if you graph this and you have 3, 7, and 7, 112, something like this. So your graph looks like something like that. And we're basically trying to find the average rate of change between the 2 yellow dots, which will give us a slope of positive 7. Question number 3, what are the real roots? Well, the real roots are those that cross the x-axis. you have two locations here. This is x equals 0, and this one is x equals -4. So that would be choice C. Let's go on to the next question. Consider the quadratic equation. Y equals 2x squared plus 12x minus 3. Well, I look at my folder and I recognize no parentheses. So if it has no parentheses, this is standard form. And we were working on identifying the A, B's, and C's for quite a bit of time, right? We've even done that back in factoring. So A is 2, B is 12, and C is -3. Did you notice how here the A, B's, and C's are never x or x squared, right? It's the numbers in front. Those are called coefficients. Coefficients. Okay, part B, what is the axis of symmetry? So it gives us an equation. Let's just write this equation out. -b over 2a. So let's just use my highlighter here. Okay, so I need the b value right here. So b is 12. And then we're going to use a value, which is 2. So let's write that out. X equals negative. The b value was 12, and 2 times the a value, which was 2. And let's just go ahead and simplify that. So x equals -12, and then 2 times 2 is 4. So did you notice I'm doing that negative sign at the very end? That's just my preference. 12 divided by 4. Remember, if you don't understand cross canceling in some ways, 12 is really 4 times 3, right? So cross out your 4s. 4 divided by 4 is 1, so I cancel out that equals 1, so I'm left with x equals -3 is my answer. Let's highlight that. For question 4b, we found in the previous problem x equals -3. And this is what goes into the middle of my graph. So from here, I think of the x number line, so -2, -1, -4, -5. You can put that into Desmos. I have a calculator here. So I'm going to go y equals, clear it, 2x squared plus 12x minus 3. I'm going to go to my table, look for -1. I got -13, -2, -19, -3, -21. You'll notice that is the lowest or smallest number, -4, -19, and -5, 13. So when I go ahead and graph these points, I'm going to go left 3 down -13. A little bit hard to see. So left 1 down 13. Something like right there. Down left 2 down 19. Left 3 down 21. And then it's symmetrical, -1, left 4 down 19, and left 5 down 13. I also notice that this graph will have a y-intercept of a -3. So this is standard form, no parentheses. It's going to go through -3. And then just use a color pencil or a pencil, and you want to make sure that it is a smooth parabola, like so. And that's what our graph looks like. All right, let's say in Desmos, I want to graph that question. So y equals 2x squared plus 12x minus 3. You'll notice the graph doesn't fit, so if you click on the gear icon or the circle, click on the table here, and then if you click on the magnifying glass, that'll zoom into the points that you want. But if you zoom out on your graph and you click on the vertex, the minimum, you'll notice that this is actually question 4b. This is your axis of symmetry. So x equals -3. So if I put in -3 and switch all these numbers, and now let's graph it. And I'm going to show you something else. So if I actually just graph x equals -3, that shows me my axis of symmetry here. So that's how you get a table of values and your graph using Desmos.
Hi there, are you tired of your old sauce being barbecue sauce, ranch dressing, French dressing? Well, boy, do we have the product for you. As we like to call it, the mathematical sauce. We have different kinds of flavoring. One is, for example, we have 2 + 2 flavor, and we also have the 3 × 4 flavor.